Where's Charlie?
I'm here.
There you are. I was gonna look to your old spot. Okay, Charlie,
Yeah.
you're gonna start us off today.
Okay.
Okay, ready?
Uh-huh.
Question one should be the easiest one, but you've also had a week off of school. So your brain may not be math back yet. We theoretically did this exact same equation probably 2.1 or 2.2. So we graphed negative 3x plus 2 and or we just used that equation. The derivative was just a flat line.
Okay.
What was the height of that flat line, or what was the equation?
Was it 2?
Was it 2?
Yeah.
Are we just throwing out total random guess?
No, just because it says plus 2.
Oh, okay, that's good logic. Wrong number, but good logic.
Oh no, was it negative 3?
Yeah, so the slope of that straight line is negative 3. And so it's the same slope everywhere. Because it's a straight line, it's the same slope everywhere. So the graph of the slopes was always at a constant negative 3 height. So 1a should be y equals negative 3. And we only know that because it was a straight line. And that is the answer to 1b as well, because a straight line has the same slope everywhere. Now that was essentially the only equation that has same slope everywhere. Every other equation we work with is a curve, which means the slopes are different everywhere. Is he supposed to call any units? Or you're giving him your number?
Yeah.
I haven't renumbered the desks yet. That was pretty good strategy though. Just curious, does anybody in here already learn the quick way of doing derivatives from their friends or siblings? Only one person? Two-ish? Okay. Usually it's like a third of the people by now. Like, once they hear there's a quick way of finding derivatives, they don't ever want to do the limit, like the big limit problems. We essentially are done doing them. G of x, if it's x squared, its derivative was 2x. H of x being x cubed, its derivative. I know this question is phrased as you guys would remember it, but I'm assuming nobody remembers the answer to those two. H prime of x is 3x squared. Now, me personally, like the way these notes are written is kind of like horizontal thinking, because everything's written as a sentence. Where some math topics for me definitely don't translate to this. And this topic is kind of one. So you might want to write it off on the margin or something. I'll basically, no, what was that equation? I'll just use 3x. Oh, it was negative 3, wasn't it? Oh, doesn't matter. To me, the pattern isn't very obvious until you see a lot of them. And the 5th power one should probably be enough where you can kind of see it. So the 3x up on top honestly doesn't actually mean really anything. if I were probably doing this, it would have been smarter for me just to write X so that it kind of matched the pattern of the rest. And if X was my equation, then the slope would just be 1 everywhere. Without me just directly telling you, choose somebody.
22.
I think you wanted to avoid 22.
I was just saying,
That's me.
Oh.
I'm 22.
Oh, don't worry, we'll call on you next time. Anything you notice? It doesn't even have to be full, correct, everything. What kind of pattern do you notice between the original equations and derivatives? So I purposely went up 1 power each time. Any kind of pattern from the derivatives themselves? Okay, I can live with that one. What gets bigger, but you are correct.
The number, like the percent.
Are we talking about the number in the front or the number on the
Number
power?
in front.
Okay. Number in the front, 1, 2, 3, 4, 5, follows the pattern. Original equations, first power, second power, third power, fourth power, fifth power. The derivatives, 1, 2, 3, 4, 5. So that's the first thing you should notice. Anything else?
No.
Oh, just no? Would it help if I did this?
Oh, the power's going up.
Okay. But the power that's going up, which is correct, how does that compare to the number in the front?
It's 1 less.
Perfect. That's all we're going with. Those 2 patterns are the only things you actually need to figure out any one of these. So forever ago, when somebody laid all of these equations and their derivatives next to each other, they absolutely saw the same pattern. Okay? A 5th powered polynomial, so I need to clarify that these are all polynomials. 5th powered polynomial, its derivative starts with a 5. Its power is 1 less. 4th powered starts with a 4, 1 less. And then that pattern is super obvious when you do any other one. Okay? If I were to write, who are you going to call on? Yeah, it really doesn't matter who. Don't call numbers because I have no idea what's what. Would you go with? 10th powered. Its derivative. What's going to be the number in the front?
10,
Okay. What's going to be the power?
9,
Perfect. So this is going to be known as the power rule. Anytime you have a polynomial that has a regular power, its derivative is going to follow that exact same rule. And that's what the front page of our notes is trying to lead us to. Like I said, for me, not as, I'm sure not everybody, everybody thinks differently, right? For me, I had trouble trying to see the pattern the way it was laid out here. Like I wouldn't just automatically put the 2 together. For me personally, I don't see patterns unless I see a bunch of them, and I can absolutely see what goes where. So, using that information, we've got x to the 50th, and Liv is gonna call on somebody who's gonna be able to tell it to me like right away.
10,
I don't know. Is there a 10 anymore? Some desks went out in the hall and other numbers were ripped off. John, what would be the derivative of x to the 50th?
X to the 50th would not be 49 no?
Say it again.
I don't think.
Okay, 50th power,
Oh, okay, so it would be 50x to the 49.
perfect. That means the first number is gonna be the power that you started with. The power will be one less than what you had. X to the 50th would mean its derivative is 49. So, the power you started with, power is one less. That's gonna be the power rule. Okay, now, before we do the bottom half of this page, I actually kinda wanna fill out this box. So this is where we'll write down the official power rules. I forgot to ask the simplest one. John, who are you gonna go with?
15.
Oh, sweet, we got a 15. What is gonna be the derivative of a constant number? So like, if I have y equals 5, perfect. The derivative would be 0 because the slope of y equals 5 is 0 everywhere. So if we are taking the derivative, this is the notation that's like a verb. D over dx is gonna be the notation that means to take a derivative. So there's no letter on top, there's no any other things, this is like the verb saying you're going to do it. So the derivative of a constant number is 0. Now, anything that can be written with a power is theoretically polynomial. And I very specifically said polynomials, but what I should have said is anything that can be written with a power. So, if I have x to the nth power, so it doesn't matter what power you got. The answer is going to be the original power times x, and then you subtract 1 from the power. So this is 100% known as the power rule. And so if you hear me talking about the power rule, or if you see it written down, the nice thing is this is going to be at least 75% of the derivatives you do will use the power rule. There are definitely equations that can't because they're not written as powers. And so we have other ways to find those derivatives. But if an equation can be written as powers, this works for it. And we won't have to do a limit, you can just immediately write the derivative. Okay? Now we haven't done all of these yet. Do you want me to write down the rest of the rules before we go to the other one? Just so we don't have to come back to this? Okay. If you are taking the derivative of things being added, so f of x and g of x, they theoretically are different functions, but you guys would consider them terms. So like if you have an equation with multiple terms, you can do the derivative of each term individually. Oh, sorry, plus or minus. So this just means that if you have an equation with multiple terms, you'll just do the derivative of each term separately throughout. So frequently you'll see K and C used as constants. They kind of mean the exact same thing. They usually use a K when it's called a scalar multiplier. So if you have 5 times x squared, the 5 in the front is called a scalar multiplier. So if you have a number multiplier, they'll write it as a K, but it's just a multiplier. So this number in the front, this multiplier in the front, does not affect the derivative. So if I have 5 times x squared, I can do the derivative of x squared and then multiply the answer by 5. So if your original equation has a multiplier of 5, your derivative also has a multiplier of 5. So it will follow with it. That's kind of the big take out of that, because it will happen no matter how difficult the equation. Okay, going back to page 1. So we've already done the difficult part of this section. The power rule is the section. This is details. I don't remember who just went.
Shoemaker.
What's the question?
I didn't ask one yet.
Oh.
That has me worried though. Say we have x squared plus 6. This plus 6 is a, the word's transformation. So you take your regular parabola and you lift it up 6. Will that change the slopes? Okay, so should this one have the exact same slopes as regular x squared? Okay, so the derivative for this one, because it's not f of x, it's y, we would write y prime. What would be the derivative of x squared plus 6?
2x.
Perfect. Okay, now, there's 2 ways to approach this. One is exactly how I just phrased it. The plus 6 just raises it up 6, and it won't change the slopes. The second way to approach it, I find more practical. Because I've got a plus sign, I've got 2 terms. I'm just gonna take the derivative of each term individually. Derivative of x squared was 2x. Like, you're gonna get used to just knowing that one, because you're gonna see it so often that you'll just be writing it down automatically. What's the derivative of 6? I think, who did I have answer that one? Maybe John? Who's the one that I asked about the derivative of a constant? Okay, what's the derivative of 6? 0. So I can do their derivatives separately. I find that easier because I don't have to memorize how a transformation affects an equation. I just do the derivative of every term individually. Okay? 5x squared.
Answer or fix one?
Your choice.
Fix one.
Pick somebody, okay.
Winston.
Winston, I'm gonna do the derivative of 5 times x squared. Okay, do you need some guidance on this, or do you think you can just tell me how to do the derivative right away? And I'm okay with either one.
Tell you.
Okay? So y prime would be,
It would be, so it would be 10x.
you're correct. I don't want the final answer yet, though. I could see you doing it in your head. The 5 from the x squared will be in the derivative. I'm assuming this is what you're doing in your head, yeah. The derivative of x squared is 2x. So 10x. Once you get the power rule down, they are you're gonna have to stop and think about them for a little while, probably like a week. After that, you pretty much will do them automatically, which is good, because that's going to help you when we learn the other weird rules of derivatives. So getting power rule down will help you a lot. So it's gonna feel annoying, but I'm going to do overkill on practicing it. Sure, we'll just go right to that. Who's helping me?
25.
I have no idea, 25. Let's go with Ella. Oh, are you 25?
I am.
Do you want Liliana to do it?
I can do it.
Okay, good. I was about to make fun of you for being so relieved to pass it on to somebody else. If I'm doing the derivative of negative 19x cubed plus 4x minus 3, so this is essentially 3 different derivatives. And I don't know, you know, for most people, they're just going to do them one at a time. So how about the derivative of negative 19x cubed?
You do negative 19 times 3x to the second one.
Perfect. So 57. Negative 57x squared plus, to do the next derivative, 4x. Actually, I don't think we talked a lot about these yet, but do you already know it? So this is like 4x to the first, and you can, whatever, you can do power rule on it, or you can just think of it as linear. They're both correct.
Does it just stay as 4x?
The derivative is just going to be 4. So it would technically be 4x to the 0. And then x to the 0 is 1. So you can do power rule on it, or you can think of it as linear. They both work. You're never going to write x to the 0. Do you want me to put it in here just for our notes for now? Maybe when you guys are looking back at this, that might help. Okay, and then the derivative of 3.
0.
Perfect. Okay, and then if you want to simplify it past that, you certainly can. So negative 57x squared plus 4. Now theoretically, we're just going to write this down once, and we're not going to actually do it. I don't know if you guys even noticed it when I was having you do derivatives with the limit. We never went above squared, and you never got more than a couple terms, because the derivative gets really big very fast. I was hoping the next person could tell me how to write this in limit notation derivative. We're not going to do it though. Should we go to 25 for that? Yes. Okay, sounds good. She didn't want to be mean, so I'll just do it. How would I write negative 19x cubed plus 4x minus 3 as limit notation derivative? So I'll start you off with this.
Would it be negative 19 x plus h to the third
Perfect.
plus
Oh God, I didn't even remotely live in this room. You can go ahead.
plus 4 x plus h minus 3
Perfect.
minus negative 19 x to the third plus 4x minus 3 over h.
I believe you said the rest right. I was trying to get the marker to work. There we go. So usually when I do the limit ones, I kind of write them out in chunks so I don't get everything mixed up. So like, here's my x plus h term. This will be f of x, which I don't know if I'm going to fit. Now the reason this would take forever is mainly because of this one term right there. Because you would have to do x plus h and then FOIL it twice. Because you need to cube it. And anything above second power takes forever doing it the long way. And so we've traditionally tried to hold off and give you smaller terms so that you can still do these but not feel totally overwhelmed. When I went through calcs, so like high school and college, they 100% made us do like fourth power, fifth power with limits by hand. Like we had to do limits for a whole month. And then a month later, they showed us the quick way. AP doesn't emphasize this. And so you guys kind of get lucked out because AP means that we pretty much skip this and go right to the quick method. So there's advantages and disadvantages to AP. But I just wanted to show you that this is a big help now because of how much time it saves. Come on. How are we feeling in power roll? Have you guys ever done fist of five? Like, don't really get it. It seems pretty easy so far. Like, I'm not trying to pretend like you guys are masters at it, but how are we feeling on it? Like, do you guys want me to do some of these problems with you down at the bottom? Do you feel like you could do them on your own already? Should we take like 10 minutes, because we go till 28. Should we take 10 minutes and see if you can answer these 4 questions already? Nope. Seeing question 2, I immediately remembered what I forgot to put in this top box. The ones that will throw you off are roots, square root, cube root, fourth root. They can be written as powers, and so you can do power rule with roots for derivatives. So, square root of x can be written as x to the half. So I'm sure you've done that in pre-calc and maybe algebra 2, but probably not much at all. In calc, we rarely ever use the root notation. We use powers. In fact, you so rarely use the root notation. I don't think anybody here has a TI-89, my guess. They're not that common. So they were the first calculators that could do calculus on them, and they didn't even have a root button because they assumed that if you were able to use that calculator, you would know to write it as a fraction power. Okay. Let's do number 2 together since we didn't do a root, and I don't think there was a root on page 1. So before I do derivatives, I'm going to rewrite the original function with a fraction power instead of a root. So 6 root x, I would write as 6x to the half. Okay, my derivative still works the same way. It just looks bad when we do it. So I've got a 6 multiplier, so my derivative will have a 6 multiplier. Anybody feel like they know how to do the derivative on the half power? I think a lot of you do, I just don't want to call on somebody for it. What are we going to multiply in the front? Not the 6, just the x to the half. So if we're doing the derivative of x to the half, what's going to be the number in the front? The original power, which was 1/2. And then the new power is going to be 1 less. So I'm going to do 1/2 minus 1. So it'd be negative 1/2 power. I mean, I semi-skipped the second term, but I think you're probably pretty good at those maths. This answer is correct. Multiple choice would never write that as a correct answer. Multiple choice would usually not write negative powers. And so a multiple choice answer would be 3 over x to the half or square root of x. But just know that on our tests, if it's a free response question, this is perfectly acceptable. On the AP test for free response, this is perfectly correct and acceptable. But for multiple choice, they will always write it with a positive exponent. Okay. Why don't you guys see if you can figure out the other 3 questions? 3 might give you a bit of pause. 4, I think is the tangent line one. Yes. Oh, I didn't even realize there was a 5th. Try 1 through 4. Kaylee, are you feeling confident enough about number 1? You can write it up there whenever you want. Oh, I didn't even notice it says f prime of 1. I thought it was just f of x, f prime of x. Do you feel confident enough about f prime of x? Okay. You can write it up there whenever you feel like it then. I don't, does anybody feel like they figured out number 3? Yeah? What did you do first? Sure. No, I understand you did the right idea, but it doesn't work.
Correct.
You have to FOIL. So for number 3, maybe I should just say that before too many people write down incorrect info. Number 3, it feels like you should just be able to do the derivative of each item, but you cannot. So I purposely, up on top, the only one I put in there is if the terms are being added or subtracted. If the terms are being multiplied, you actually can't do that. So on number 3, you have to FOIL that out before you do the derivative. Oh, you just put 1 in? Sure. Wait, pause. I'll have you erase it.
Okay. Did I do that wrong?
Only because the derivative was wrong.
Aha.
So you had the right idea,
Okay.
because you were doing the power rule,
Mhm.
where it went off. See right here where it's 3 times
Oh,
2?
yeah.
You wrote the new power instead of the
Okay.
original.
Yes, yes, yes.
So that would be 3 times 3. And he did that on the second term too.
Otherwise, yeah.
Yes, everything else was correct.
Yeah, yeah, okay. Oh my gosh. It's not really
I
good.
shouldn't laugh, but it does it to me too, so.
And then I did that for.
So then that would be 9
That'd be
times 2.
2.
Yep.
Okay. So it'd be, oh my god.
Yes, everything else was done perfectly.
Okay, got it. Jeez Louise. So it'd be 9.
Yep. -5?
Yeah, so -9 plus.
Yep. Perfect. Nice, thank you. Does anybody need help foiling out number 3? I don't know. You guys got a week off. I don't know how much you forgot here. It's pretty much the same reason why the people who are planning on retaking tomorrow, I tried to tell you not to do it after break, because like, you forget a lot of stuff. Calc is super easy to forget. The more complicated something is, the faster you forget it. Somebody feel pretty confident about number 3? I mean, you're welcome to write it up there if you want. If you're not feeling confident, that's fine, I'll put it up there. I just thought I'd give you guys a chance. Before I forget too, for Kaylee's problem, the notation was perfect until here.
Should be F prime.
Yeah, you did the problem right. So as we go throughout the year, this notation over here was correct and good. As soon as you plug in one, you'll want to write what you did. And so by putting that in the front, you're saying what you did to whoever's reading your problem. And it's not like you have to write it constantly, but that just describes what you did. The foiling, I didn't even notice it's WY. So what would we get? 2y squared plus y cubed minus 8y minus 4y squared. So those two you can combine together or do the derivative separately. It'll work either way. And then number 4, I really wanted to see if you guys could remember how to do a tangent line. Because it's been a week. I'll put up the answer for number 3 while you guys are working on 4. Number 4, I read it too quickly when I was trying to tell you what problems to do. Number 4 doesn't want the tangent line answer. It wants to know which x values are parallel to that. So it wants to know which tangent lines have the same slope as this one. Your derivative is all of the slopes for the whole line. So you're going to make your derivative equal to -2 because that would tell you which x's from all of them would be equal to -2. And to solve a quadratic, it has to be equal to 0. Should I scroll it up more? Sorry. So when you're solving the quadratic, it has to be equal to 0. Okay, since we're running up on the end, and this went pretty quickly like I expected it to, I actually don't think you guys are gonna have any trouble with the power rule. I think where you're gonna have most of the trouble is all the different style of questions there are, right? Like tangent lines, derivatives of roots, all variety of types of questions. Would you guys feel comfortable having a work day tomorrow, having a quiz Wednesday? Okay, let's do that then. So I'm kind of hoping the work day tomorrow will be where you get all of your questions answered. So we rarely ever have work time in here. And so if you guys can take advantage of it, that would be good, especially if you're having any troubles with section 1, 2, or 3. Section 4 is good, it feels drastically different. Like from here on out, all of the sections in calc, we don't use limits, we don't, like the problems aren't gonna be as slow as they were because of the setup. Now that we can find derivatives quickly, the sections will feel different. And I don't know if that's better or worse, but just, it feels different. I don't know if you tried 5 yet or not. Maybe I'll try to give you a minute to try number 5. So then, if nothing, you guys can have your notes finished so that when you come tomorrow, or should we do that tomorrow at the beginning of the hour to refresh your memory? Sure, I can do that. Why don't you guys take the last 5-6 minutes to look over the homework to see if there's gonna be something you're gonna run into trouble with. So that tomorrow, when you have work time, you can ask about it.